Hello and welcome. Today we'll try and solve some of the Kubernetes security challenges provided by KodeKloud learning platform. So in front of us, what we have is challenge number 1. And in this challenge, we have 6 images listed in the diagram on the right, which is this diagram. Using alpha-xyz Trivy tool, we should identify the image that has the least number of critical vulnerabilities and then use it to deploy the alpha-xyz deployment. Secure this deployment by enforcing the Apparmor profile called custom nginx, and later on we'll be exposing this deployment with a node port type service and make sure that only incoming connections from the pod call middleware is accepted and everything else is rejected. So in this diagram, basically by clicking each of these icons, we have a detailed description on what needs to be done in order to solve these smaller tasks. And by successfully solving these little tasks, we'll have our challenge number 1 done. So let's dive into it. Oh, and by the way, we can move these icons around freely, which is pretty neat. If one feels the need to rearrange them, they can do so. I'll start at the bottom. And what we have here is some nginx images with different versions, and we'll be using Trivy tool to find the image with the least number of critical vulnerabilities. So I'm going to list these images first. And what I want to do now is merge these two columns, the name and the version one, so that later on I'll be able to automate this process of scanning with Trivy tool a little bit. Let's sort a little bit. All right. So I'll be using some bash to make things faster. And now that the Trivy tool is scanning these images, what Trivy is basically, it's an open source vulnerability scanner. It's being designed for container images and applications. It detects security vulnerabilities in the dependencies and packages of container images. It's pretty easy to use and can be also integrated into DevOps pipeline to automate the scanning process. It supports various image registries such as Docker, Amazon Container Registry, and also Google Container Registry. So here are our results. It failed the last one. It couldn't parse the reference. Yeah, I think that we'll do this one manually, but I think that the critical vulnerabilities will be the same as with the nginx latest. Just a quick addition here. Using nginx without specifying a version tag will always pull the latest stable version of the nginx image available on the Docker Hub. But on the other hand, using nginx latest specifically pulls the most recent version of the nginx image available on the Docker Hub, regardless of whether it's a stable or development version. All right, now let's try it. Okay, so as far as this task is concerned, we want to use Nginx Alpine in the deployment later on, because it has the least number of critical vulnerabilities. Okay, so let's move on to the Apparmor. We should move the Apparmor profile to a folder listed here on the control plane node. We should then load the Apparmor profile called custom nginx and ensure it is enforced. Okay, I'll copy the profile first. And let's load it with next command. The profile that was being loaded is called custom nginx. Let's check this out. Yeah. So we can see that the correct profile was loaded. So let's move on to the persistent volumes. What we have here is persistent volume called alpha-PV, and it's already been created. We should modify it and inspect the parameters used to create it. So we have a persistent volume in the namespace alpha, and we also have PVC that should be bound to alpha-PV. So let's check if this is correct. And we can see there is no claim by this PVC yet. So, and the status is available. So let's check the alpha-PVC persistent volume claim and edit it using correct specifications. So we'll be able to use this claim. And as we can see, we should change the access mode to read write many, which I'll do. The rest seems fine. Let's check if there are any changes with the PV now. And there we go. We have a claim and the status is bound. Okay. Let's move on to the deployment section. We should create a deployment called alpha-xyz with the image that has least critical vulnerabilities. It's what we did before with Trivy image scanning. Deployment should have exactly one ready replica, and there should be a data volume mounted on the pod. Okay. So the replicas is already set to number 1. Let's add the Apparmor profile. And the profile was called custom nginx. Let us use the correct image. And what we also have to do is use a volume mount to mount this data volume. And let's use persistent volume claim to claim the alpha-PVC into the pod. There we go. Let's check our progress so far. The deployment alpha-xyz was being created. Okay. So far, so good. And let's move on to the services. But before we do that, let's check this little task. So the middleware pod should be able to connect to alpha service on port 80. There is no service now. No, there is no service yet. So let's create one. And by doing that, let's expose the alpha-xyz deployment. We should use cluster IP, type of service, and it should be exposed on port 80 and target port 80. So if we define a Kubernetes cluster IP service with the port 80 flag, the service port will be set to 80, which means that the service will listen on port 80 for incoming traffic. If we also define a target port in the service configuration and set it to 80, then the service will forward incoming traffic on port 80 to the pods associated with the service. So these are also listening on port 80. So in this case, the service port and target port will be the same, which is 80. And you don't have to specify it twice in this case. Okay. We also have this pod external that should not be able to connect to alpha-xyz on port 80. Let us try this now. We can use telnet or netcat. So as we can see, it can connect to the service now. You could also use netcat by using this command. Yeah, so what we can see it can connect to the port 80 to this service. So we'll have to change this now by enforcing some network policy rules. Okay. So we should create a network policy called restrict inbound in the alpha namespace. Policy type will be ingress. So Inbound access only allowed from the pod called middleware with label app middleware. Inbound access should only be allowed to TCP port 80 on pods matching the policy. So network policies in Kubernetes are a set of rules that define how pods in a cluster allow or deny network communication with each other. They are used to control traffic flow between pods and enforce security policies within a cluster. And with network policies, Kubernetes provides a way to apply network segmentation and firewall rules to containerize workloads running in the cluster. Network policies can be also used to specify which pods are allowed to communicate with each other based on labels, IP addresses, ports, and protocols. This helps to limit the attack surface of a Kubernetes cluster and prevent unauthorized access or data leakage between workloads. And I have to say that there are no deny rules in network policies. Network policies are deny by default, allow explicitly. So it's the same as saying, if you're not on the list, you can't get in. So imagine going to a club on a Friday evening or Saturday evening and not being on the list. Well, you cannot enter the club. So it's a sort of an analogy on how things work with network policies in Kubernetes. I'll use this skeleton. We don't need the egress rule. I'll paste it. So we should change a few things now. First, name. Namespace is alpha. Pod selector. So let's see what the labels are in the pod in the deployment alpha-xyz. So this is what we'll be using as our match labels. We won't be needing IP block. Also name selector. So the inbound access is only allowed from pod called middleware with label. So we'll be connecting this to only. And we'll be using labels provided here. And the port should be set to 80 with the protocol TCP. Let's create this network policy. Okay, so now we've created this network policy, and let's see if we can connect from the pod external to service alpha-xyz now. And as we see, we can't. So the network policy is working. Let's check if we have the complete solution. And there we go. The first challenge is being solved. Thanks for watching. and see you in the next one. Bye.